Okay guys, now in chemical thermodynamics, let's get into processes. Now as I already explained, it's universe, it's surrounding and then system. So we are dealing with surrounding and system right now. Initially the process that we get involved into is isothermal process. Isothermal, adiabatic. And we would be initially trying and understand isothermal process and then get into adiabatic process and then try and see how are these two processes different from each other. Just to clarify, isothermal process is a process where when I am doing a reaction, say A plus B giving you C. So if it is at 40 degree, the reaction goes on at 40 degree only. Alright, if the reaction is going on at 40 degrees Celsius, throughout the reaction would be carrying on at 40 degrees Celsius only, irrespective of whether it is exothermic process or endothermic process. In my earlier videos, I have talked about exothermic and endothermic processes. Now, in case of just to recap, exothermic process, this is enthalpy of reactant, this is enthalpy of product, and this is the quantity of heat that is liberated to the system. So the system gets heated up. Like for example, I'll just give you an example. If I take calcium chloride, if I take a test tube, alright, and I water in it and I put calcium chloride into it. As soon as I put calcium chloride, the entire water will get heated up. Alright, so heat is provided to the system. That is what is exothermic process. Alright, so heat is provided to the system, so system becomes hot. Heat is provided to the system, so system gets heated up. That is what is exothermic, and this is the quantity of heat that it liberates to the system. Alright, okay. So what is endothermic process? Similarly, endothermic process, now see, this is enthalpy of reactant, this is enthalpy of product, this is energy profile. Alright, so this is the amount of heat that it is taking from the system. Alright, so for example, suppose again I take a test tube, water in it, I put ammonium chloride into it. As soon as I put ammonium chloride into it, shake it a bit, you'll find that entire this would get absolutely cold, and it would get so cold that outside we would see droplets, water droplets condensed. So why is it so? Because it has taken this much heat from the system and it has cooled the system. Alright, so that's the difference between exothermic process and endothermic process. Alright, now let's get into our system. Now when we are talking about exothermic process, this is the system where we are carrying on the reaction, and our reaction is A plus B giving you C. Alright, now this reaction occurs at 40 degrees Celsius. Alright, we are carrying out the reaction at 40 degrees Celsius. This as well as this. Alright, now this is exothermic. Let me talk about exothermic reaction first. So here, as I explained, it gives out heat. So see, 40 degree, initially it was 40 degree Celsius, we carried out the reaction. Now since the reaction was exothermic, so it gave out heat to the system. So the temperature of the system, it gave out heat to the system. So the temperature of reaction mixture rose to 60 degrees Celsius. Alright. Now we are calling it as isothermal process. That is, the reaction has to be at 40 degrees Celsius only, even if it is exothermic. How does it happen? Now here it is surrounding which comes into picture. Now there's surrounding around here. So what surrounding does? It takes Q calories of heat, which is equivalent to say 20 degrees Celsius. Alright, and it pushes back the temperature to 40 degree. Alright, so that's how surrounding comes into picture. So surrounding picks up that excess Q calorie, which is equivalent to say 20 degree Celsius, takes it out and puts it back to 40 degree Celsius, as a result of which what happens is the entire process for entire time is maintained at 40 degree Celsius. Alright, so in spite of reaction being exothermic, in spite of reaction giving out heat, that heat is absorbed by surrounding, since surrounding is there. It's absorbed by surrounding and the temperature is again retained back to 40 degrees Celsius. Alright, understood this part? Exothermic? Fine. Now let's come to endothermic process. Now in endothermic process, what happens? As I told, it takes heat from the system. So same reaction carried out at 40 degrees Celsius, but since it's an endothermic process, so what happens is it takes heat from the system. So 40 degree cools down to 20 degrees Celsius. Now 20 degrees Celsius, so what? Same process. Here in this case, surrounding took away heat. Here surrounding would be providing heat to the system, and the system would get back to 40 degrees Celsius. So this is what is interaction between system and surrounding, that maintains the temperature, owing to which the system is isothermal. The process is isothermal. Alright, so surrounding has to be there to take care, to either take it out or to provide, either to provide Q calories or to take out Q calories. Surrounding has to be there. Alright, so that is what happens in case of exothermic process and endothermic process. Alright, fine. Now let's talk in terms of change in temperature. Did we find any change in temperature? We didn't find any change in temperature. So del T was equal to 0. Change in temperature, because initially also we started at 40 degrees Celsius and it maintained at 40 degrees Celsius only in spite of it being endothermic and exothermic. Why? Because of the surrounding. So there was no change in temperature. So del T, del is difference in temperature, T1, T2, initial and final. No change. So del T is 0. Now you know every body, even if it is stable like that, wall stable, this stable, but particles inside it has vibrational energy into it. That is what we call as internal energy U. So is there any change in internal energy in this system? No. Why? Because internal energy is function of temperature. Temperature rises, internal energy also, vibration also increases. Temperature is low, vibration also is low. Alright, so energy, internal energy is function of T. So if change in temperature is 0, then even change in internal energy is 0. Was there any exchange of Q calories? Yes, there was. So if there is any exchange of Q calories, then we say it's not equal to 0. Del H is not equal to 0. Del H is equal to 0 provided there is no exchange of Q in between system and surrounding. I hope you understood this process well. Alright. Okay. Now similarly we talk in terms of adiabatic system. In case of adiabatic system, the temperature here in case of isothermal, the temperature shot up, but surrounding took care of it and brought it back to its original temperature that it started with. Alright, and even if the temperature went down, surrounding provided calories to bring it back to its original temperature. So isothermal. Whereas in case of adiabatic, let it happen. If the temperature is rising here 60, so let it happen at 60 degree, and if it is cooling down, let it happen at 20 degrees Celsius. Why? As in your case, today's generation, parents are there to take care. Alright, so any shocks, any sort of problem, parents are always there to take care of you. Surrounding here, there is no parents here. Alright, so vacuum, there is no surrounding over here, so exposed. Alright, so in this case the same thing is happening, but what is happening is, since there is no surrounding, since there is vacuum, so what happens is there's nobody. In this case we are talking in terms of exothermic. In this case the temperature rises, it stays there only because surrounding is not there to take that Q out of it. Alright, same thing happens here also. It gets cooled, surrounding is not there to provide Q to it. Is that very clear? So let us try out with del T. Del T Is there any difference in temperature? Yes, since surrounding did not take out Q, did not give Q, so del T changed. Alright, so change in del T, difference in temperature, is not equal to 0. Why? Initially 40, then 20, initially 40, then 60. So there was del T is not equal to 0. Now since del T is not equal to 0, so del U is also not equal to 0. Alright, now since, why? Because U, internal energy, is function of temperature. Then was there any exchange of Q? There was no exchange of Q. So since there was no exchange of Q, so del H is equal to 0. As I explained over here, del H would not be equal to 0 provided there is exchange of Q calories, whereas here there's no vacuum, no parents around to take care. So what happens is, here you have got to face the consequences that you have created. Okay, so 40 goes to 60 remains at 60, and 40 goes to 20 remains at 20. So that's the difference between isothermal process and adiabatic process. I hope you get it. Alright.